having more electric field intensity for a unit, if having a unit of electric field intensity will be E is equal to, because from it can be derived from the formula, so E is equal to F by Q naught, and we know that force having the unit of Newton and Q naught is the unit of is charge and unit of coulomb. So it is a unit per coulomb. And there is another unit of electric field intensity, that is a volt per meter, and we can also derive that kind of that unit from the potential gradient. We know that potential gradient is due to the distance changing from the charge E is equal to del V by minus del V by del R. So because if the distance changing, there is a change in the distance, so the potential change is changing. So this is called potential gradient. So we can derive from the unit of electric field intensity. Also from there, that is a volt per meter. Volt is the unit of potential, and M is the unit of distance, that is a meter. So this is a unit for the electric field intensity. So now we know that for the electric force, because this is a force, and definitely according to the Coulomb law, if a charge I have driven over here, so the charge is the positive, and this Q charge, if another charge is entering in the field of this charge, that is a Q naught, a unit charge, it is entering over there. So definitely these two charges will experience electric force. We called it the Coulombic force, and we studied it earlier. So because these two charges are getting closer to each other, so according to the Coulombic force and Coulomb law, we have said that if the same charges will approaches to each other, so the force of attraction, the force of repulsion will be there, and if the different charges will approach to each other, so definitely the force of attraction will be there. So regarding this phenomena, these two charges having some kind of a distance in between them, and when this charge will enter, this charge will move towards this field, so definitely the distance will vary, and we can say that the Coulombic force will be there. So I can write it as, we know that Coulombic force, according to Coulombic force, because one charge is Q and another charge is Q naught, so I can write it as, therefore according to the formula, K, one charge is Q and other charge is Q naught, and in the formula I have shown that Q1, Q2, and I already told you that Q1 is the charge 1 and Q2 is the charge second charge. So now the both charges are here in the form of Q and Q naught, so I have put it over Q and Q naught. So by putting this value in this formula, we will have some kind of another formula. E is equal to F is K Q naught divided by R square divided by Q naught. So by rearranging, we can write it as Q naught divided by Q naught and R square. The Q naught and Q naught will cancel each other, and we will have another relation, that is E is equal to K Q divided by R square. So now you can see that we have some kind of a formula is equal to, that is the formula for the electric field intensity. So KQ divided by R square. So now we also know that charge is a constant quantity having a constant magnitude, and K is also a constant quantity, 9 multiplied by 10 to the power 9 Newton meter square per Coulomb square. So I can write it as E is equal to constant divided by R square. So now I knew that if I will remove some kind of a proportionality sign, then I will put a constant over here or over there. But now I have a constant over here, and whenever I will remove this constant, so I will put a proportionality sign. So this will be like this: E is proportional to 1 over R square. So according to this relation, I can say that, so whenever one charge will get closer to the another source charge, and the test charge will get closer to the another source charge, so the distance is getting closer and closer, getting small and small. So according to this relation, they are inversely proportional to each other. So it means that whenever the distance will be decreased, or distance will be get smaller, so the electric field intensity will be get stronger and stronger. So more the close charge, the test charge is more closer to the source charge, will experience a more strength, more force on that charge, and as compared to when it will move away from the charge, the test charge will move away from the source charge, so it will experience a less amount of strength on that, because moving away and away will lose the charge too. So it means that this is inversely proportional to each other. It means that greater the distance between the source and the test charge, so having less amount of force on that kind of a charge, or less amount of strength on that kind of a charge, or that kind of a test charge. But a charge will get closer. When a charge will get closer to the source charge, so it will definitely increase the strength on that charge. So this is the basic relation of the electric field intensity. So it means that whenever the test charge will get closer to the source charge, so definitely it will be having a varying strength on that kind of a charge. So I hope you like the lecture, and please do not forget to subscribe and press the bell sign, so it will notify that whenever I will upload my new lecture. So if there is any question you can ask. Assalamu alaikum.